Okay, now let's go to discuss the uniform distribution. This is a very important distribution because of two reasons. The first reason is this distribution is used for the discrete variables, and at the same time could be used for the continuous variables. That is the first reason. Second reason is for the uniform continuous distribution, the probability is very easy to calculate. Normally, when we are talking about the continuous distribution, when we find the probability, we have to use the integration. That is a little bit complicated, but for the uniform distribution, that will be easy a lot. So now, if we assume that x is a random variable that is uniformly distributed between the lower bound and the upper bound, in here will be the a and b. Its probability density function has a constant height. That will be the 1 divided by the b minus a. From this graph, what we can learn is any value from the a to the b, there is a probability. The probability is a 1 divided by the b minus a. And any value lower than the a or bigger than the b, the probability is 0. And this is the uniform cumulative distribution function. From this graph, what we can learn is the probability for any values lower than the a is 0. And the probability will be increased from 0 from the lower value of the a, gradually increased to the 1, and it is stopped at the value of the b. And for the uniform distribution, we use the u, bracket a and b to define this distribution. And because we have already discussed for the continuous distribution, their probability is the area. So in here, for the continuous probability function, the probability will be the area under the curve. So for the uniform continuous distribution, the area will be equal to the base times the height. For the base, that will be the b minus a, and for the height, that will be the 1 divided by the b minus a. So totally will be equal to the 1. Since the probability density function is a rectangular, we can easily verify that the area under the curve is totally 1 if we summing all of them together. It's a base times a height. For the uniform distribution, it is quite popular and it's very useful for the business analysis, especially for the what if analysis. Normally in the situation that what we are care is only the worst situation and the best situation. In this kind of situation, in this kind of the case, we will plan to use the uniform distribution because there is a lower bound and there is an upper bound. And the other thing for the reason for people to use the uniform distribution is because this is a very simple distribution. So we don't need to make any assumption about the distribution in the between the lower bound and the upper bound. However, because of that, we very probably, when we are using the uniform distribution, we have missed a lot of important information. For example, like the central tendency, like we have already discussed. When we're talking about a normal distribution, most of the data, they should be concentrated around the mean, and we can find the value for the standard deviation. However, in the uniform distribution, the standard deviation will be higher than the normal distribution. So if the data generating situation has any central tendencies, the assumption of a uniform distribution will lead to a higher standard deviation. And that could not be very appropriate. So what we can learn from this part is, if what we care is only the worst situation and the best situation, uniform distribution is a very good choice. However, we have to be very careful. If we choose the uniform distribution, very probably we have to make sure the central tendency of that data is not important. If we know, if we have information about the central tendency and the standard deviation of that random variable, uniform distribution may not be a good choice. And when we're talking about the distribution, we care two things. First one will be the parameter. Second one will be the PDF and the CDF. For the parameters, there are the two parameters for the uniform distribution. There will be the lower limit and the upper limit. And this is the formula for the PDF, the probability density function for the uniform distribution. And this is the formula for the cumulative distribution function. However, for the uniform distribution, you can see the mean and the median, they should be same, will be the balancing point of that distribution. So the mean and the medians, all of them, they are equal to each other first. And then the value will be the A plus B divided by 2, which means the lower value plus the higher value and divided by 2. For the standard deviation, that is a little bit complicated. The standard deviation will be equal to the B minus A and square them divided by 12 and square root of whole value. So now let's go to an example. One important reason for us to go through the uniform distribution is because it is very easy to calculate the probability. Normally in the final examination, it's very hard to find some question ask you to use some knowledge from about the integration. But for example, like to calculate the area for some smooth curve. But for the uniform distribution, they are very easy. It is rectangular, so it will be easy for you to find the probability. So this is an example from our textbook. Most doctors, they believe the effectiveness of a drug, it followed a uniform distribution. And its lower bound will be the 15 minutes, and the upper bound will be 30 minutes. So we said that A will be equal to the 15, and the B equal to 30. For the first question, will be asked will be the calculated the mean and standard deviation. And for the mean, we put the lower bound and upper bound, 15 and 30, into the equation. We'll get a value will be equal to the 22.5. For the standard deviation, they'll be exactly the same. We put the value into the equation, you can get the standard deviation of that random variable. Another part is to calculate the values between calculate the probability between two values. For example, like in here, we calculated the probability between 20 to the 25. So what we should do is we need to use the B minus A times 1 divided by the B minus A. But actually, you can see for the 1 divided by B minus A, that is exactly equal to the PDF, the probability density function of that distribution. So for that question, this is A, this is a B. So for the first part, will be the B minus A, will be the 25 minus 20. And the times is probability density function, will be the 1 divided by the 30 minus 15. Finally, the result will be the 5 divided by 15 and equal to the 0.33. So that is for the uniform continuous distribution, and there are several examples in the textbook, so please have a look before you attend the tutorial.